My name's Joe Purcell. I work at a company called Bounteous. We have a few different offices, but two of them are here in Chicago. I've been working with PHP for, since about 2003. Probably for the last 6 years or so. I've focused mostly on Drupal. We're hiring, so if you're looking, come talk to me afterwards. Something else that's new, I'm a new parent. That is, okay. Well, it's interesting because, your day-to-day is just very different.
Is this your first?
This is the first, yeah, for us, yeah.
How long?
He's 6 months old.
Oh,
so
that's really fun then.
yeah, so I'm enjoying that a lot. But it's funny because when I think about, who am I? Certainly professional things that are relevant, but sometimes the personal bits are fun to talk about. A few years ago I was inspired to add this slide, and I wanted to add this again to this presentation to just say thank you to people who helped get me into Drupal. Coming to a camp like this is a great opportunity to just say hi to somebody you've never met, and who knows, maybe the next thing you know, you'll be writing your own contrib modules or contributing back, or maybe you find a solution to some problem you're working on. But I've personally found the Drupal community to be very helpful. So I throw this up there just as encouragement to you all to meet new people. I am expecting that you all have some experience with unit testing. This is an intermediate talk. It'll be more advanced for some, less so for others. If you're not, if you would fall in more of a novice with unit testing, that's okay. I'll try to take it a bit slower with the parts that are really relevant and pause for a question or two. And then for those who have done a lot of unit testing, what I encourage you to do is to take the ideas I'm sharing, mull them over, and let me know if it jives with you, if it resonates with how you think about unit testing. In the Mythical Man Month, it's a book published by Fred Brooks years ago. This is actually on the cover in it. He's talking about how projects large and small have gone through challenges, whether it's budget, timeline. You launch the product and it's no longer relevant. Every project has, if you've been doing this long enough, you've certainly gone through this experience where you feel like the gravity of the code base or whatever the challenges are in the project are just weighing you down. And so doesn't matter if you push really hard and you get one paw up out of the tar pit, another paw is sinking down again. And I like this to frame up the problem that we're talking about, which is quality software. And unit testing is one way that we can help ensure quality on our work. I find myself surprised by running into the same problems over and over again, but if we're to solve them, then we need to be clear about what the problems are and the solutions that we're proposing. So something that you'll hear me talk about several times over and over again is about coming to a clear definition of what unit testing is that we all agree and adopt. There's two things I want you to come away with. One is, what is unit testing? And the other is when it's valuable. Because not every scenario is going to be a good scenario for unit testing. So if you can come away and you can articulate these two things, I'll consider it a successful session. The way we'll go about this is I'll start with a definition. I'll talk about two principles. I consider these principles because regardless of the language or testing framework you're working with, these two ideas are going to be relevant. And if you can understand them and execute them, you will be able to do unit testing well. I'll go through two examples using those principles. I'm actually going to skip the test smells section just for a matter of time, and I'll talk about motivations at the end. The motivations is the fun part. I will say this is more of a I don't want to say it's a dry talk, because I personally find it really exciting to talk about the nitty-gritty details of coding, but I'm not intending this to be like really entertaining. So there's going to be a lot of knowledge sharing. So please speak up if you have a question. Yeah.
Can you, since you're skipping test smells, can you just take a minute to describe what it is?
Yes, I certainly will. Yep. Yeah, I actually have one slide I will go over with test smells. So. Okay, definition. Raise your hand if you feel frustrated by the inconsistency of definition about unit testing and other types of testing. You feel like it's a bit ambiguous. So about half the room or more? Okay. So in my journey through unit testing and other types of testing, I'm repeatedly frustrated by the definition. I find it, in conversation, you end up in these circular logic, and then you realize, oh, we're not talking about unit testing. We're really talking about integration or functional or UI testing. One challenge with the definition is that pretty much every testing framework has its own definition, either implicit in how it talks about testing methodology or explicit. If you go, I've gone through every book that I could find about unit testing. Pretty much everyone has a different definition. Blog posts, podcasts, everybody's talking about unit testing in at least nuanced in different ways, sometimes very different. What I'm going to present here is what I would consider a consolidation or but what is common that I see across those definitions. So what you take away, I do expect will be relevant, even if your team or the blog post you're reading treats it differently. The concepts here should apply. So what is a unit test? I've found the Wikipedia page most often quoted, which is interesting because it's like just a huge paragraph description. In the XUnit testing book, they actually put the definition in a glossary at the back of the 1,500-page book. I want to bring that to the front. Martin Fowler, in a post, phrased it as it being a situational thing. Let the team decide, for their purposes, an understanding of the system, what a unit test is. I like this because it gets at the heart of it. Ultimately, your team needs to own unit testing if you're going to do it well. But he also calls out that the software development community simply hasn't settled on well-defined terms around testing. And I want to do better. I think we can do better. So I'm going to take a crack at it. Here's my proposed definition. A unit test verifies a unit's correctness against a specification. So what I like about this is it gets back to the roots of formal verification and mathematics. Some of those terms are used there. You could think of a unit as a function, a method on a class, or a script. I think the third one, sometimes we don't consider this, but you could consider a script a unit of code because it's something you can invoke. It's one thing. And if you've used a step debugger, it might be helpful to think of it as one frame in the call stack. So here, this is getting a cache ID. You could think of that as one thing. Or you could go up the stack and say, the middleware's handle method is a unit. Very simple example. Here's a function called increment. It takes a parameter and it returns that parameter plus one integer. So it's incrementing by 1. And there's the test here. This is a simple test. Most of my examples are going to be PHPUnit. So this shows a very basic way to test it, to verify that if you pass the integer 1, it returns the integer 2. So here in our test, we call increment with the integer 1, and we're writing an assertion that says the result of calling increment with 1 is the integer 2. And so this should pass. When you're looking through the Drupal code base, and when you're talking about unit testing, I think it's helpful to talk about the levels of testing. The simplest or lowest level is what I'll call solitary unit testing. I'll explain what I mean by solitary, but you'll see the unit test case in Drupal, and I think that kind of corresponds to what we're talking about there. Or there might be sociable unit testing, which is a little higher level, and you'll find the kernel test base class is used for a bit higher level than the unit tests, and then functional testing, which browser test base would correspond to that. The thing that's confusing, all these can be done in unit tests, in PHPUnit. So bear with me as we take a step back from specific frameworks to understanding high-level conceptual, like what are we talking about with unit testing. And I'll do a quick analogy. I don't know if this will stick, but maybe for some of you it'll help. This is a photo of a bridge that's been built, and they're testing it by driving a coal train across the bridge. And there's a person underneath inspecting it to see if there's any faults in the concrete or whatever. This is not a unit test. Like once you have the whole thing built and you're testing the thing as a whole, that is not a unit test. But so in this image, I show a steel beam that maybe is used in that bridge, and before it goes into the bridge, you're doing a stress test on the steel to make sure it meets some kind of whatever the regulation is. So maybe it's amount of pressure put on the beam. So does that make sense?
Yes.
Okay. Principles. All right. So if you don't come away with anything, pay attention to this part, because these two principles, I think if you can really understand and adopt them with your team, I think it'll make unit testing go more smoothly. How many of you know what a test double is? If I use the phrase test double, a couple of you. That is the first concept. So I use this image. It's if you haven't seen Black Panther, the Marvel film, I encourage you to do so. It's a really good movie. On the left, you see Denai, who's playing the character of Okoye. And on the right, you'll see Janisha, who's the stunt double for her. So some of the action scenes in the movie are actually played by someone who kind of looks like Denai, but has some of the skills and training to do some of those stunts. What's kind of interesting about Janisha, she was a professional wrestler. She was part of the U.S. national bobsled team. She did taekwondo and gymnastics. And for the film, she would train like 8 to 10 hours every day for weeks leading up to the film. But the point of this image is that a test double is two things that look very similar, but they're different. So one is meant to impersonate the other. The reason we use test doubles is cases where we have indirect inputs, and I'll show an example of what that looks like. You might also call this shared state. So it's information that is used by different areas of the code base. An easy example would be pulling data from a database. The other scenario where you use test doubles is indirect outputs or side effects. So maybe you're writing to a database. You might use a test double there. You could think of it as anything that makes it not a pure function. And if you don't know what a pure function is, make a note to go read about it. PHP is not, there are some languages that are purely functional languages, and it's interesting to read about them and the problems that are introduced when you have a language that's not purely functional, like PHP. An example of an indirect input, so we have a function called getProduct. In it, let's assume that this is loading that product from the database. That's an indirect input. Why is this a problem? Well, when you execute that function under a test, if you don't have a database, there's an exception. There's no database to read from. So a test double can be a replacement for having a live database. An indirect input would look something like this, where we're calling increment product favorite amount. I'm making this example up, but just imagine you pass a product to this function, and what it does is it increments the favorite count and then saves that product. Well, if you try to execute that under a test and there's no database, it'll throw an exception, right? There are 5 different types of test doubles that you can use. A dummy is never called. It's just a class or piece of information that's needed to actually instantiate the class or unit under test. A fake, it's similar to a dummy, but it is called. So a dummy, you never call it. You never interact with it. But maybe it's a parameter that has to be passed in. But a fake, you would actually call it and interact with it. And the fake, you would likely have hard-coded information into the test double. A stub is similar, but typically a stub lets you provide indirect inputs in your test. So you can vary what the indirect inputs are. A spy, it's similar to a stub, but it's also going to capture your indirect outputs. And we'll show an example of what each of these are. So just kind of take a moment to absorb these. And then the last one is a mock. And it provides indirect inputs and it verifies indirect outputs. Something that makes me disappointed is when people say mock and they really mean test double, because mock is just one type of 5. There's 5 different types of test doubles. So let's go through some examples. So imagine we have a test, and in this test we want to verify that this voter class by default grants the created permission. And so we set up a token dummy, because this is just a piece of data that's needed when I call the vote method. We create another dummy and pass that in to our vote method. Something to call out here is that the token dummy, the first one, in PHPUnit you call getMock, and what it does is it returns an object that is a double of the class you pass in. So what's cool about that is if you don't want to have to deal with some of the parameters, like construction parameters of the class you want to dummy, you can do that by just calling getMock. You can look up some examples if you want to know more about that. Or maybe you can just pass in a standard class. So the object dummy, in this example, it required an object, but by default, it's never called. So I have to pass it in, or else, because if I don't, it's going to fail. But I don't necessarily have to have information on the object. So this is an example of where a dummy can be used. And in this test, I'm verifying that a binary file response by default is setting the XXL redirect to the path of the file. So here I set up a fake file, and you can see this is a fake file class. Now imagine, I'm not showing the code here, but imagine I'd gone and created this class called fake file, and it has all the methods and such on it, but it's never like reading and writing from disk. It just, if there's a read method, it just returns some hard-coded values. I pass that into the binary file response, and what that does, it allows me to run an assertion that says that header is the path of the file that I set. So fakes can be used when, I think a file system is a really good example. If you write a fake file, you can use it in all kinds of tasks, and you never actually have to have a file system. A stub lets you provide indirect inputs. So in this case, what I'm showing here is that this authorization checker class, the isGranted method, will return true. So I mentioned that with PHPUnit, you can get a double of a class. Another thing you can do once you have that double is you can say, all right, this method is going to return a particular value. And you can do that with whatever method is on that class. So in this case, we do it so that when we instantiate our controller and check if it's granted, we want to assert that that's true. And granted, this example is a bit contrived, but you can see how stubs, all it is you're passing in indirect information, right? Like I did not pass true into the test controller. I passed an object that had a method on it. A spy, there's a library called Prophecy, and you can use it in conjunction with PHPUnit to capture indirect outputs. So in this case, what we're doing is we're creating a fake user, or a double, I should say a test double of a user. You pass that into this profile class, and then we're going to assert later in the last two lines, we're going to assert that when you call get full name, it's going to call the first and last name. Now you're not asserting that like this avoids having to create an actual user with the first and last name and validate the output is like the full name is the first and last name. This lets you just know, like, okay, when I get full name, it's calling these two methods on it. Again, a bit contrived, but hopefully you get the idea. A spy is capturing what methods were called. A mock does something similar. This looks similar to a stub, but there's one difference. So here we're saying that the get first name should be called one time. So here's the get first name method. We're even specifying what value should be returned, and then we're expecting that the last name is going to be called. And what's different between a mock, a stub, and a spy, yes, they're all providing indirect inputs, but a mock on execution will it'll throw a failure if this is not called. So a mock does its assertion during runtime. One thing, and this is one reason I don't care for mocks much, is your assertion is not clear. Like you would have to read in your setup, in your test, you would have to read there for where the assertion is. So we'll come back to why that's a problem later. But what should you double? So when should you use test doubles? There are different approaches, but I'm going to categorize it as it depends on if you're doing solitary or sociable unit testing. So going back to our bridge analogy, when you take a unit and you're only testing that in isolation, that is very solitary. So it's similar to that example where you have a steel beam and you're testing its endurance. Sociable would mean that you have more things, more code being executed during runtime that you're testing. So how do they differ? I actually took this idea from Jay Fields. He wrote a book called Working Effectively with Unit Tests. And how he describes the difference is that sociable testing will cross some boundaries. And we'll talk about what a boundary is here in a second. But solitary will never cross boundaries. With sociable testing, you'll have one or more concrete classes during test. But with solitary, you only have one. So during solitary testing, you only have the unit you're testing that's instantiated and running. A boundary is a database, a queue. It could be a network call. It could be a collaborator. So if you're looking at a bit of code and you see it calling a method on another class, that other class would be outside the boundary of that unit. You might think of this as single responsibility. That might be another way to think of a boundary. So if it's calling a method on another class, that other thing is not the responsibility of the unit you're testing. What does one concrete class mean? This means that any dependency you have in a class, you would use a test double for. So if you're testing a class, it's got 4 constructor parameters. Each of those should have a test double if you're doing solitary testing. It also means that collaborators that return objects should return test doubles. So if you have a collaborator that returns another collaborator, that class should also be doubled. Because again, it's solitary, it's lonely, nothing else is going on. Statics violate this. So Drupal uses a lot of statics. If you use Laravel, it has a lot of static calls. Strictly speaking, if you have a static call and the unit that you're testing, that would violate this principle of solitary testing. One caveat to that is a value object. So if you have a class that has no behavior at all it's doing is just returning data, I would say that that's an exception. So you can have that class instantiated during runtime and still follow this principle of solitary testing. Because in that case, I would consider that object to be a data construct and not a class that has behavior. This moment, your head might be exploding, and you may not be sure if it's a whole bunch of knowledge or just confused. So let me recap what we just covered, and then you can ask some questions. So a unit test verifies unit's correctness against a specification. Use test doubles for indirect inputs, and there's 5 of those. A boundary is an indirect input or output. With sociable testing, you can cross some boundaries and have multiple classes during the test. And in solitary, you never cross boundaries, and you only have one concrete class during the test. Any questions? Everybody tracking okay? Okay.
Question.
Yeah.
So with unit testing, would that also encompass like testing for outliers? Like for that first one you had, you're doing something very specific, you're expecting a very specific to come out of it. Would you also have, as part of unit testing, testing your outliers that you're not thinking about? Or is that part of a different type of testing?
So the question is, with unit testing, would you test for outliers? Or maybe you could phrase it as positive versus negative testing. Like, I know the specification of my test. I pass an integer, and it should return that integer plus 1. But should you have a test that says, what if I passed a string? Like, what's the return value there? I would argue that that type of unit test is often more valuable than the positive case. And you probably have more unit tests about the negative cases than you do the positive. Error handling and edge cases in software is important. I think in web development, many times that goes overlooked because of the criticality, right? Some websites, it's not, like the impact of one of those edge cases might be pretty small. But in other areas of the software industry, that's really important, like aviation. Like if you're not testing for an unexpected scenario, that's a huge liability, right? So does that help? So yeah, like the short answer is yes. Yeah. Any other questions before we move on? And we'll talk a bit more about that. Okay. All right. Principles by example. So I pulled these from Drupal. I'm going to go through these a bit quick, so I won't pause for questions. This is more for us to look at these things and exercise those two principles that we saw. So when I look at this batch storage class, and I look at this load method, and say I want to unit test it, there are a couple things that would make this difficult to unit test. Not sure if you see those things yet, but I'll call them out. This method assumes that you have the ability to start a session. Do you have session storage set up before you're executing this? Sometimes your testing framework already handles this for you, but if it doesn't, you need to account for that. It's also assuming you have a database. Do you have a database when you're running this? How does that impact the speed of the test when you're running it, to have it? It assumes that you have some service to get a CSRF token. Let's go through an example using a mock. So here's our test, and the test that I want, or my specification, is that I just want to verify that loading a batch is going to start the session. So here I mock the session start. So this is saying that the start method is getting called. And this is actually our assertion, remember, because a mock actually does the assertion of your test. I stub the input from the database so that I don't have to have a database running. I dummy the CSRF token because I don't actually need a value. And then lastly, I execute the class under test. So this works, right? Like this is a unit test that works, but can we make the assertion more apparent? And this is where knowing your test doubles can be helpful. So let's try it using a spy. So here we have a whole bunch of setup, and I don't call this out, but you can see where I'm using a spy. That first line is creating a test double using the Prophecy framework. And this line I've highlighted, we're calling the class under test. And our assertion is called out here at the end. So this is called, this practice of Arrange-Act-Assert means that all of your setup is done at the top of your test. You're acting on the unit under test, and then all assertions happen at the end. So remember how I said that I don't care for mocks too much? This is an example. You can't really do Arrange-Act-Assert using a mock, but you can do it using a spy, so it makes it a little more clear. Second example, this one's going to be more complicated. And if you have trouble tracking, that's okay. We'll run through it, and I want to go on to some other things. So this is a maintenance mode subscriber that I pulled out of Drupal 8. there's a lot going on here. See if you can spot the indirect inputs, indirect outputs. There's a few of them here. We have a static call, 2 of them. We have a function call. We can't solitary unit test this. So what I'm going to propose is that we refactor it so that we can unit test it. But before we refactor, we want to have a test to make sure that we're not breaking anything, right? So long story is, write a higher level test that maybe has the database, delete the untestable code, we'll re-implement it later, break the class into 2 responsibilities. So we're going to have one that's just checking, or one that's just generating the maintenance page. Because we don't want to assume that every page is going to be HTML. It might be JSON, it might be XML. And the other responsibility is going to be determining if the maintenance mode page is turned on and should apply. We'll write our unit test and then eventually delete our higher level test because we don't need it, because we now have a unit test. I'm just going to show kind of how this would play out with separating the responsibilities and writing the unit test. So responsibility 1, one thing that's cool about PHPUnit, you don't actually need an implementation of an interface to use a test with it. So remember I said getting a test double, it just creates a double of the class. So as long as my implementation is looking for the interface and not the concrete class, I can write a whole test suite just with the interface and not having any concrete classes that actually exist. So let me go back. So this here is, this class is going to be responsible for getting the response. So it's going to read the accept headers, detect if it needs to return JSON or XML or HTML or whatever, and return the response. I'm refactoring the maintenance mode subscriber to just check that the maintenance mode applies and whether the user is exempt from that maintenance page. Everything else is now handled by that other class. So now we can test it pretty easily. I say easy, but unit tests with doubles are difficult. So here we get a test double for our account. We have 3 dependencies to account for. The account, we stub the maintenance mode. So we say maintenance mode is turned on. We stub the response. We stub the request, and then call the unit under test and make an assertion. So the thing we're asserting here is that if the maintenance mode is turned on, that a applicable maintenance mode page implementation can set the response. What's great about this, so what we just did is like we took this class that'd be hard to test and we made it testable. By doing that refactoring, our class does one thing now. It's good, single responsibility, solid programming. We can test one thing. The class has 3 dependencies instead of 7, so we're now decoupling our code. It's more readable, it's easier to test, and it's abstracted so non-HTML responses can be returned. So I don't know if you read it, but anyway. Let's see, what time do we got to be out of here? We got 10 minutes? 2:30? We got about 10 minutes? Okay. So, yeah, 10 minutes? Okay.
Oh, we've got till 2:30.
20 minutes.
Great. Okay. I love these Boromir memes. You don't simply write unit tests. Like I think that on a high level, many people are on board with unit testing is good. But once you dig into code, you can see that some code is really hard to test. When you have a whole library or code base where you're using TDD, or you simply have a legacy code base and you want to write unit tests for it, you're going to run into problems. And that's where you get into test smells. We won't cover all of them, but there's a book by Martin Fowler called Refactoring, and in it he itemizes different code smells. If you look in the XUnit testing book, they talk about test smells. Both cases are when you're looking at code and working with code, and you find something that's really stinky, it's hard to work with, that's a test smell. So it doesn't necessarily mean that there's something, it doesn't always mean somebody did something wrong, but it smells. So the example that Martin Fowler refers to is if you have a kid, a baby, and you need, like, when do you change a baby's diaper? And the advice that he got was, well, if the diaper stinks, you should change it. So the principle of test smells applies here too. So if the test or code is hard to work with, then change it. So I won't go through all the test smells because of time, but I left the slides in here, and at the end I'll give you a reference to the slides so you can look at them later. So if you're doing unit testing on your team, maybe check this out. There's some what I think is good advice in there that I pulled from other people. It's not mine. Motivations. So this is the fun part. Actually, I don't want to show that yet. So imagine. Let's look at this picture. So this picture is of a bridge, and I got this from a friend of mine. And imagine you're in a remote area. The bridge is made of wood. There's plenty of wood around. The bridge might be mostly pedestrian traffic. It looks like the bridge that it's going over, it's not like a big cavern or gorge or something where if someone fell off the bridge, they'd be severely injured. It's a relatively safe area, let's pretend. How valuable would it be to spend months of preparation on and lots of money building a steel bridge here? Well, maybe steel isn't abundant. Maybe it's easier to, like, if a board in this wooden bridge is worn out, they could, like, easily replace it. So I'm, like, painting this, like, fictional scenario. I don't know if it's actually true of this bridge. Unit testing wouldn't be very valuable, like, or at least it would have lower value, because the impact and the cost of it would be low. Bear with me. Let's contrast that scenario with, say, one of the bridges downtown Chicago, where it's a 2-level bridge. You have pedestrian traffic and vehicle traffic on the lower level, and above it you have the L train. And the L train, or the CTA, there's 750,000 people who go across this every day on average. There's a huge impact. Like, if anything fails, if there's a single bolt that, like, comes undone and causes a failure in this bridge, that's a huge deal, right? So in these two scenarios that I'm trying to paint, is like, there are scenarios where unit testing has a high impact and a lot of value. And I think that there are some that are not. Give me feedback if you think that analogy works. That was, like, something that I've been
On that first picture, yeah. I wouldn't necessarily just drive my car or truck across that. I'd run out and jump up and down. And I'd pre-test it. A lot less expensive testing,
yeah.
Right?
Yeah.
Just
Sure.
get there and look at it.
Yeah. So the comment is, looking at this bridge, I wouldn't necessarily drive my car on it.
Until I tested it.
Until you tested it.
But with a really cheap
Yeah,
test.
right. Yeah, like the train test that I showed earlier, where, like, you build the thing and then run a train across it and see what happens.
If I was with you, you'd say, hey, Mike, go on. And if you come back, then we'll drive across.
But let me spell it out in a different way. So let's go beyond analogy. Rule of 3. If you have 3 classes or 3 areas of code that's using a particular unit testing would have a lot of value. If you're writing a library, if you're writing something that other people are using in their composer, JSON, please unit test. If you have legacy code that you're planning to refactor, unit testing can help make sure that you're not breaking things as you're refactoring. If there's a high amount of necessary complexity, so encryption, compression, like certain algorithms, maybe a sorting algorithm, sometimes there's code that doesn't really make sense to decouple. Unit testing is going to have a lot of value because you can't break it out into simpler parts. Exploratory work, test-driven development. There can be a lot of value to forcing yourself to sit down, write a unit test, and then write the unit that implements the test or makes the test pass. Going back to the bridge in Chicago, if there's even a high cost to very minor bugs, unit testing is going to have a lot of value. If you're writing in a framework, so this is kind of similar to if you have a composer dependency, you want to make sure that your framework code is solid. When does it have low value? If you're writing glue code, so what I see glue code is like if you're writing maybe like a theme hook or something in Drupal, I don't know that there's a lot of value in unit testing that. Like what you really care about is you want to be able to assume that Drupal's doing its job and that you're wiring up something so that the presentation is correct. You probably, in that scenario, you probably have more value from a higher level test because you don't have like a lot of unique complexity in the units of code you're writing. There are some exceptions, but just broad stroke. If you're writing glue code, unit testing probably has low value. Maintenance cost is significantly higher than the cost of a bug. It also applies to some websites. You're writing code in a platform. This is probably similar to the first one, but I'm just saying that like, if you're writing code that's stitching things together, you would probably benefit more from, say, an integration test than a unit test. There's a more valuable form of testing, like using integration or UI testing. Solitary or sociable. I had to throw this in here. So sociable unit testing, I think what helps, so this image is somebody made these cabinets, and you can't open a drawer all the way because the cabinet comes at a corner where the drawers butt up against each other. Like, you may have tested to the extreme each one of these drawers individually, but until you've put things together and tried it in combination, those unit tests were useless. They didn't, I'm not going to say useless, that's too harsh. But they didn't surface this problem when you have the whole application working together. So that's one value of sociable testing, but it's hard to debug. It requires a lot of setup and teardown. You might need a database, right? It requires a lot of testables. If you've ever had to write a kernel test in Drupal 8, you'll know what I'm talking about when it comes to sociable tests can be difficult. Solitary, it allows higher code coverage. So you have more control over the scenarios you're testing. It promotes decoupling. Remember the example we went through? We refactored and split things out to make it easier to test. It executes faster and enables better software design. Simon Honeywell has a book called Functional Programming in PHP, and he made a comment that stuck out to me. It should not be underestimated how much easier these functions, in referring to pure functions, how easier they are to test than their state-filled counterparts. So when you're writing code and you want it to be testable, consider if you can avoid shared state and side effects. I would say that solitary unit testing forces you to write good code. All that said, if you know the story of the Lorax, there's the onceler who comes into this area that has lots of resources, and he builds and builds and builds and essentially destroys all the resources that are there. And the Lorax is pleading with him, saying, look, I know you're focused on production, you're focused on churning out that code, but unless you pause and like consider the impact of, lobbing code into a release, you may be foregoing severe implications of the problems in your code. And the Lorax says, unless someone like you cares a whole awful lot, nothing is going to get better. It's not. Talking about unit testing is great. Talking about software quality is great. But ultimately, it's going to come down to the people, the developers, who are close to the code to speak for it. So in the story of the Lorax, it says the trees have no tongues. Code doesn't speak for itself. Like, you all are the experts of the code. You speak for it. An easy example. Friend of mine, he sent me a Slack message, this was a while ago, and he said, this is why Drupal 8 is good. And he was referring to someone who had pushed back on a code submission, saying this is simply too much code for a blind commit. Supporting comments won't help, we need tests. Like, this isn't, like, this is it. Like, this is where, like, that Lorax hat comes into play. Like, you are the one to really make a difference. If you have a code base and you don't really know where to start, I'll give some suggestions. And this really applies to like frameworks and places where unit testing has high value. There's a tool called PHP metrics. For this graph, I actually use an older version of it because it lets you generate this chart where it shows cyclomatic complexity along the y-axis. Cyclomatic complexity is a measurement of, essentially a measurement of how many different paths there are through a function. So it's a metric of how complex your code is. Efferent coupling is along the x-axis, and this means how many dependencies are there in the unit you're working with. The more dependencies you have, then the more devils you need, right? If you want to do solitary testing. I've been doing this analysis on Drupal 8 for a while. This one's on Drupal 8.6. Since 8.3, this plot has not changed much, but I want to call it a few things. You'll see there's some entity-related classes that have high complexity and have a lot of coupling. I think those are good examples where you may want to look at that. You may say, look, we don't want to decouple this. It's too complex. We just want to keep this in this class. But what I'm saying is, if we want to look for areas where unit testing might have high value, high complexity, a lot of coupling, if you unit test those, potentially break them out and decouple them, then you can focus on making more clear assertions and assumptions about what your code is doing. Yeah. And then I call out a few different examples. There's Form Builder. Archive tar is a class that has really high complexity, almost no coupling, so it doesn't need, it's not depending on a lot of other classes, but high complexity probably because of all the compression it's doing. But if you look at that, it's like one big file. There might be benefit to breaking that out into separate files so that you can unit test it. Symphony, yeah.
5 minutes.
Oh, 5 minutes. Okay, great, I'm almost done. Symphony is really successful with reuse. If you go around to different frameworks and platforms, like Drupal is using some Symphony components. Why is Symphony so successful and being reusable? I'm not saying this is like truth, but I have some observations. It's good object-oriented code. If you read some of those Symphony classes, they're pretty clean. Not too many cases where you look at it and you throw up your hands. You may not be familiar with it, right? But not like archive tar. No surprise, the tests are mostly, if not entirely, solitary unit tests. Not all of them, but there's some kernel tests. But I wonder if we did more solitary testing, if our frameworks and libraries would benefit a lot from it. So remember the two principles: test doubles, solitary versus sociable. Thank you. Please provide feedback. Rate the session. Here's a link to the slides. I'll come back to that. Contribution day is on Saturday. You don't have to know code to contribute. There's actually, we'll be doing some Drupal 9 readiness work, so come join that. If you're new to contributing, there's a training by Amy June at 10 o'clock to noon. We have like 4 minutes for questions. Yeah.
So what do you use on your team to help like automate ensuring that you have proper test coverage? What tools do you find that's most useful for you?
Depends on the language. Oh yeah, yes, thank you. I usually remember it. So what tools do I find useful for testing?
For automating the test coverage, for example.
Automating test coverage? I've used Coverall. Like, if you want a test coverage report to see what code does not have a unit test, there's a service called Coveralls that I've used. I'm sure there's others. Does anyone know of a test coverage report tool? So that's one that I've used before. I'm sure there's others, but I think Circle CI does. It's kind of like Travis. It's like does a build task in the cloud. I think they have a tool for it. Any other questions, comments, objections? Okay. Yeah.
What type of issues have you experienced when, like, for example, you're like trying to get more unit tests done, or like how do you deal with, for example, when you have like a project that's on a tight deadline, and you have a project manager saying we need to get this stuff going, but you want to take time to do all the unit tests, spreading this out. How do you?
If I had, so the question is, what problems have you experienced you have a deadline, but you need to do the unit tests? If I had an answer to that, I would share it. The short, I'll give a quick take, and then Mike, if you have. What I found is that there needs to be, the stakeholders need to weigh in. Like, you have a choice. You understand. It's like the Lorax. It's like the once layer. If you want to push this through, you can, but it's at the cost of this practice that we believe will help us control the pollution in our code base, or the things that are incorrect. It'll help us root out bugs. Mike, what?
And along the same lines, if you're not using Agile, then consider it. Because if you start down the process, if you start your processes with an Agile methodology, where testing is built into each sprint, and you get your stakeholders involved with the process, and they attend the sprint planning meetings, and they are responsible for the sprint review, if they see a lack of quality, if they see a lack of test plans and expected results versus actual, if they see a lack of unit tests, they'll they'll push back, and they'll help people speak up more.
Yeah.
So, and a lot depends on the team. You have to get your team. Everyone has to be on board with quality.
Yeah. So Mike was saying, if I summarize this well, that agile methodology will help here. If at each sprint review they can see what has test coverage or not, and they can weigh in and say, weigh in sprint by sprint and say whether more time should be invested in testing. Yeah.
It's not to leave the testing till the end.
Yeah. All right, we're at time, but maybe one.
I'll follow up.
Yeah. Come talk to me. I'm on Twitter. Reach out to me. Thank you all for coming.